The research question for this segment was, what does emission duration depend on and not depend on? The hypothesis we had to test was that emission duration observed in chemiluminescent glow sticks is completely dependent on energy input and completely independent of the emitting fluorescent dye. Emission duration is the length of time that light is being emitted in a glow stick. Although emission spectroscopy cannot indicate emission duration, it can be used to determine if light emission is still occurring.
Emission duration depends on the reactants present and the amount of energy put into the system. Energy is initially supplied through the chemical reaction between the activator and the dye. In our experiment, after the first minute of heating, the reaction rate sped up because the heat catalyzed the reaction. Catalyzation causes reaction rates to increase, making less energy required for a reaction to occur. As a result, the particles of the dye and activator had more energy, leading to more frequent interactions because they were moving faster and had more collisions. This increased rate of reaction causes photons to be emitted at a higher rate, also meaning higher emission intensities of the dyes after heating. After some time, the concentration of the reactants, the dye and activator, decreases, since most of the reactants have turned to product. This means less photons are being released, so the intensity peaks also decrease, despite the addition of heat. This trend continues until one of the products runs out and the reaction stops. If this experiment had been conducted without the addition of heat, the reaction would proceed at a much slower rate, and less photons would be emitted per unit of time compared to when heat is added. The amount of dye and activator still remains the same with or without heat, so the emission duration with the addition of heat would be shorter because the dye and activator turn to product at a faster rate. Thus, the input of energy catalyzes reactions and causes emission duration to decrease.
In a glow stick, the energy is initially supplied through a chemical reaction between the fluorescent dye of the glow stick and the activator. The electrons are being excited to a higher energy level. This catalyzation causes the reaction rates to increase, making less energy required for the reaction to take place. However, once the reactants are depleted, then the reaction is forced to slow down. This is similar to a rocket because a rocket will start out with no energy. But once there's an input of energy, then the rocket will begin to speed up. However, once the input of energy runs out, similar to the reactants being depleted, then the rocket begins to lower in speed until it returns to its resting state.